Oh, maybe it was.
Yeah.
The soccer game got canceled.
Oh, maybe it was. How are they leaving?
It's at North Stokes. They started.
Oh, they are playing. They're playing earlier. Okay. Let's say. Okay. Yeah, it's a real game because they were supposed to play it Friday.
They had to get there.
Okay. All right. So, the quotient rule is going to be g of x. So the order matters very much on this. On the product rule, the order did not really matter because it was a plus sign in between. But the order matters very much on this. So g of x is your bottom term. It goes first. So it's g of x times f prime of x minus f of x times g prime of x all over g of x squared. One thing that lots of calculus teachers use to help kids memorize this is this low d high minus high d low all over low or low squared, whichever way. So, yeah, it was. It was in part of their song. Yeah, it was in part of Liam's. And so, the bottom part is low, and the top part is high. So, it's this part right here is your low, and then this is d high, so it's derivative of the high. And then you've got high and d low is the derivative of the low. And then in the bottom, you've got your, oh wait, wrong color. In the bottom, you've got low squared or low, whichever one you want to say there. So let's listen to Austin and Trevor's song. It was very good. Let's see if this, no, that's on the wrong thing. All right, let's switch it over.
But the thing is, you only left at like 2:15. Yeah.
That's not on the.
Let's go.
Oh, I've got that. Okay.
Absolutely not.
Okay. I think Silas Coley also had a. He was the hype man in the background making a lot of the noises.
Talking about that quotient rule. You already know. Here we go. I walk into class, open up my book, make sure that I pass. Derivatives, that's what we working on. Working on my homework from dusk till dawn. One day in Calc said she got a little secret. I start to listen because you know I want to hear it. She says the quotient rule is gonna help you out a lot. I said, what's that? She said, boy, let me tell you what. Low D high, is high D low. High D low, where the bottom. Where the bottom, how we roll. Low D high, is high D low. High D low. It's the quotient rule, man. You already know. Barrel on the mic, you know who it is. I know the quotient rule won't help me hate this quiz. Getting money, getting cash, yeah, you know the biz. Now watch me count all this money while I talk to relatives. It's the chef game, yeah, you know we go. Getting all the days with that quotient rule. Taking the relatives with all the drugs that I'm making, yeah, boy. You know, you just came back from swimming in that credit, like drowning, baby. Yeah, you know it. Mixtape, cooking conversation, baby.
It is very long. Liam's was 3 minutes and 14 seconds exactly.
Oh my god. Oh my god.
Yeah, so it does not have to be that long. But, you know, that one I play every year because even though their, like, quality of their rapping was maybe not the best, I thought it was very creative. Really loved the way they included lots of normal themes of rap songs like they did, and thought it was hilarious. So something like that was like easily a 10-point one. Liam's was probably even a little better. We'll watch it another day too because it has question rule in it. So it's out there if you want to do it there. Now let's look at how to use the question rule. Okay, doing these problems is not, getting the derivative for these problems is not all that difficult. The difficult part for these problems comes in simplifying them. So if this is a free response question, it is not all that bad because you do not have to simplify it. But a lot of times these are on the multiple choice section. So what I want you guys to do as you are working on these tonight is check the answers in the back of the book and try to get your answer to match what they have in the back of the book. It's not quite the same as multiple choice, but it sort of makes it like that because a lot of times you may have the correct answer, but you haven't simplified it the same way they have in the back of the book. So if we're going to take our derivative here, our dy over dx, we are going to have to do low, so that would be x squared plus 2x, put it in parentheses, so like that's our low. Then we're multiplying by the derivative of the top, the derivative of the high. So the derivative of 3x minus 4, what is it? 3. Just 3, right? Then it is a minus sign in between here. And we're going to have high, make sure you put it in, if it's more than one term, put it in parentheses. So 3x minus 4 times the derivative of the low, which is going to be 2x plus 2, all over low squared, so x squared plus 2x squared. It is usually not helpful to simplify the bottom. You usually just want to leave it alone. But the top is almost always going to be combined and simplified for that. So, like at this point, if it is a free response question, like on an FRQ question, if the only thing they asked us to do was take the derivative, on an FRQ, we can stop here. You do not have to simplify or clean it up at all. And there will be times where that might be what you want to do. But most of the time these are on multiple choice and they are not going to leave the answer like this. So the difficulty comes in simplifying this. You would need to distribute your 3 here. You'll get 3x squared plus 6x. Right here, be really careful because this one has a minus in it. So whatever you get over here when you multiply these together is going to have to get a negative distributed out to it. So I am going to put a parentheses here and do it as a separate step so I don't get mixed up on that. So 3x times 2x is going to be 6x squared. And then I usually do these two pieces together. This part's going to give me 6x. This is going to give me negative 8x. Together, that's going to be negative 2x. You can do them as separate steps if you need to, but it'll save you a step if you do it that way. And then you got to multiply here to get a negative 8. All of that over x squared plus 2x squared. Another really important thing on this, make sure you write that denominator every time. A lot of kids skip that and then just throw it back in at the end. And they can count off points if you do that because you're writing things that are equal to each other that really aren't equal to each other if you don't copy the whole thing. So make sure that you do keep that denominator there. I'm just going to do this to distribute that negative. That'll make it a negative 6x, a positive 2x, and a positive 8. And then I'm going to combine my like terms. So I will have negative 3x squared plus 8x plus 8 all over x squared plus 2x squared. Occasionally, that numerator may factor further or cancel. I don't think this one does. I definitely don't think it's going to factor into like an x squared plus 2x, so I think you could probably just stop here. Oh, excuse me. Okay, questions? All right, let's go to our next one. This particular problem is going to be more difficult because we have a complex fraction, right? We've got the 1 over x right there. I would do something to deal with that 1 over x before I try to take the derivative here because it makes it extra difficult to try to take the derivative. So you have a couple options. You could get common denominators, or you could just use a negative exponent to deal with it. I think I would rather just do a negative exponent because what I'm afraid will happen if I do common denominators and like get rid of the complex fraction first, I'm afraid I will spend a lot of work on that, and I'll take the derivative and still have a lot to simplify. If I use negative exponents, I'm just going to say this is 3 minus x to the negative 1 over x plus 5. So you don't have to do much to get ready to take that derivative if you do negative exponents. I might regret it after I take the derivative. I can't remember which way I did this last time I did it, but I know that both ways will work, so we're just going to do it this way. So if I'm taking my derivative, we're going to do low, which is x plus 5. It's more than one term, so I'm going to make sure I put it in parentheses. If it's not in parentheses, it's going to be wrong. There. So low, d high. So the 3 will just go away when you take the derivative. For this negative exponent, we'll have negative times negative 1 will give us a positive 1. X to the what power? Negative 2 power. Right there. The 1 right there is not really necessary, but if you want. But. All right, and then we'll have minus. We got high, so parentheses around this. 3 minus x to the negative 1 times the derivative of the low, which is just 1 in this case, all over x plus 5 squared. So, even though I have negative exponents, I can still distribute this, and I think that's what I would do here. I've got x times x to the negative 2. This is x to the first power times x to the negative 2 power. You add your exponents when you multiply those together. So I'm doing 1 plus negative 2, which is going to give me x to the negative 1. And then I'll get plus 5x to the negative 2. And then that 1 right there really does not do anything when I distribute it. The negative, good gracious, what happened there? All right, the negative here really needs to be distributed. So I'm going to have minus 3 plus x to the negative 1 all over x plus 5 squared. I could combine these two x to the negative 1s, so that would be 2x to the negative 1 plus 5x to the negative 2 minus 3 all over x minus 5 squared. Oh, it's a plus. Sorry about that. On free response, we really could have stopped at the first step, right? You've taken the derivative once you've used the quotient rule. It's probably unlikely that they're going to leave those negative exponents right there. So I would probably now change it back to fractions. So you'd have 2 over x to the first power plus 5 over x squared minus, I'm going to make this a 3 over 1 right here. Because since everything else is fractions, we're going to need that last number to be fractions as well. So what I would do here is I would get common denominators so that I can flip and multiply. So what should I use for my common denominator there? X squared. So this one needs just needs a single x in the top and bottom. The middle term does not need anything because you already have x squared in that denominator. The last term will need an x squared to go with it. So that will look like this. We'll have 2x plus 5 minus 3x squared over x squared divided by x plus 5 squared. And so at this point, we can make this bottom part a fraction and the top part a fraction, and dividing fractions is easy as pie. Flip the second and multiply. I'm also going to write this as negative 3x squared plus 2x plus 5, because usually we write those in descending order, over x squared times 1 over x plus 5 squared, and then that would look like this. And I think that'll probably be left like that. No, it won't factor. So you would just leave it like this. So again, this is probably what you're going to see the final answer look like on a multiple choice question, but on a FRQ, theoretically can stop here on an FRQ for that. Okay, questions? All right, now something you need to be aware of. You do not have to use the quotient rule for every division problem. So here is an example where we certainly could use the quotient rule here because this is a quotient. But we do not have to use the quotient rule on this problem. Because in this case, we only have one thing in the denominator right here. So we could use the love connection on this before we take the derivative. So we could divide both of those by x squared. That would look like this. X to the third divided by x squared minus 4x divided by x squared.
Can you not just do like the long division too?
Yeah, you could use long division. You'll get the same answer if you do that. And then this will be x minus, and what will I get right here? I'll get 4 over x, but that is going to be kind of hard to take the derivative of because we haven't taken the derivative yet. We're just rewriting this to make it more simple. How could I write that so it would be easier to take the derivative of there? 4x to the negative 1. If you use negative exponents there, now you don't have to use quotient rule at all. So notice this whole time I'm calling this f of x because I have not taken the derivative. If I graph the original and if I graph this, it's the exact same graph, right? They are the same. It's just a different way of looking at it. But now I want to take my derivative, and since I have got everything in this form, I don't have to use quotient rule. I can just use the power rule, which is a lot easier to use. So right here, this is just going to be 1. And then over here, I'm going to multiply my exponent by my coefficient. So I'll get positive 4. And then I'll subtract 1 from my exponent. I'll get negative 2. And they might leave it like this. They might write this as 1 plus 4 over x squared. They might even do x squared plus 4 over x squared. How do you get from here to here? You could do common denominators. So like you could put this over 1. You have to multiply by x squared on top and bottom. And honestly, the AP exam does not have a set way of leaving it, and any 3 of those, they would leave the answer choice that way. So that's one reason I'd like for you to look at the back of the book, see what the back of the book leaves as the answer, and try to get your answer to match that whenever you're working on your assignment. Okay? All right, let's do one with some trig. Okay? If I use quotient rule for this, I will have low, which is sine x, times the derivative of the top. And so the derivative of 1 would just be 0. That would go away. What's the derivative of negative cosine? It will be positive sine. Because the derivative of cosine is negative sine, but you also have that minus there as well. So it's going to be positive sine. So, it gets a little confusing. This was your low, and this is your derivative of your top right there. Minus high, make sure you got parentheses here, 1 minus cosine x, times the derivative of the low. What's the derivative of sine x? Cosine x, all over sine x squared, which we'll typically write this way, sine squared x here. So this was our high, this was our d low, and then there's your low squared. What's sine x times sine x there? It is sine squared x. This cosine right here gets distributed. So we would have, I'm going to do this. I'm going to do a parentheses. I'm not going to try to do those two things at the same time because if I distribute the cosine and the negative, it's easy to get those mixed up. I'm going to have minus cosine x minus cosine squared x all over sine squared x. And then I will have sine squared x minus cosine x plus cosine squared x all over sine squared x. They will probably not leave the answer this way. This is where some trig identities are going to come back in. Does anybody see anything we could replace? Sine squared. You could do it that way. You could do 1 minus cosine squared. Yeah. Yes, that you could do either one of those two things. So you could either put the sine squared and the cosine squared together and replace it with 1. That'll be a little bit quicker because you'll go straight to having 1 minus cosine x over sine squared x. But if we did what you said, we'd have 1 minus cosine squared x minus cosine x plus cosine squared x, and these two right here would cancel, and you'd get 1 minus cosine x. So that would work as well there. So you can either replace sine squared with 1 minus cosine squared, or you can take that sine squared plus cosine squared and replace it with 1. They are probably not going to leave the answer like this. They could, but they might not.
You change the bottom to 1.
We could change the bottom to 1 minus cosine squared x. What can we do then? Nope. You cannot mark them out.
Can
Because
you not cancel one of them?
you cannot. You might accidentally get the right answer. If you do, I think your sign's going to be wrong though. Because you have a plus or a minus sign in between these, you cannot cancel one of those cosines. They're not multiplied together. Any other ideas? You don't really have a GCF, but factoring is the right idea. The bottom, how could we factor the bottom? 1 minus cosine x times 1 plus cosine x. And so the 1 minus cosine x can cancel with this 1 minus cosine x. And I will get, make sure you put a 1 as a placeholder in the top. 1 over 1 plus cosine x. Now, they may choose to stop at any of those answers along the way. They are all equivalent. But my guess is the back of the book is going to have something that looks more like this.
Why did we not cancel as we just did? Like, if we just say marked it out and then left a 1 on top and 1 minus cosine x on top.
You wouldn't have the right answer. It'd be 1 minus cosine x, and it's supposed to be 1 plus cosine x. Yeah.
I didn't have that on mine.
All right. So, your assignment for tonight is, let me look at it to make sure this is right. Page 154, 7 through 12, and 29 through 30. Let me see if it's the same thing. Let me make sure it's the same thing. Okay, yes. Wait. What page was this again? Let's see. Question 24. Yeah. Let's see. 7 through 12. Yeah, 7 through 12 should be relatively straightforward. 29. Let's see. Let's make that 30 through 35 right there. And I will let you skip 2 of your choice, okay? It could be out of any of them, but my guess is the ones you want to skip are probably going to be 30 through 35 there. There are a few in there that are like that love connection problem where you do not have to use the quotient rule. So they are easy and quick as long as you recognize it. You can skip 2. So you can skip 2 problems. Out of all of it, but my guess is the ones you're going to want to skip are probably between 30 and 35. They're a little harder. 30 through 35 does have some product rule problems in there too. So some of them are not quotient rule. Yeah, like what you did last week. So Yes. What to do with the paper? Here's the new seating chart if y'all want to see it.
Oh, we got a picture.